here is your review for 1.7 from what we did during first year chem. So 1.7 is about periodic trends. So really we're going to cover just one of them in this video, and that's just going to be atomic radii, and then everything else I will do direction and instruction on in September. All right, so periodic table. We have this amazing reference in the periodic table. It looks so simple, it looks just like a bunch of squares, but there are so many things that you can learn about the atoms based on the way they're arranged, because the reason they're arranged the way they are has to do with the structure of the atom. So we have repeating patterns or periodicity, and we can make predictions about atomic properties when we don't actually have data. So the atomic properties that overall you're going to be learning before the first test include atomic radii, ionization energy, electronegativity, and electron affinity. For the review, the one I'm going to expect you to work with is atomic radii, and which is nice. This is actually the base of everything else we do. Okay, so what you need to be able to do is compare two elements and determine how their atomic radii compare, and then also give structural evidence. So again, definition of atomic radii: measure from the center to the edge of the atom, or about the edge, because it's not like a sharp sphere that actually has an edge. All right, so right away, let's go back to the structure of the atom. So again, the atom, the electrons are structured as shells. Talked about this in 1.5. So each additional shell, again, our periodic table, everything in this group has one shell, and then two shells, three shells. So that corresponds to these three. You'll notice the more shells you have, the larger the atom. That is one simple thing. If we're comparing things that have one shell versus two or three, and sometimes you'll hear me refer to these as energy levels versus shells, the more energy levels it has, the larger the atom is, period. All right, so if we start to look at the data to support this, again, we've got our theoretical, or really the data we have first, and then we're trying to come up with a model of the atom that explains the data. So we look at the atomic radii, and PM stands for picometers, not something you need to memorize, but it's just good to have a sense. Pico is 10 to the -9th, I believe, because angstrom is 10, could be 12, I don't know. Pretty sure it's 10 to the -9th, could be wrong. So we've got hydrogen, which is 53, lithium, 152, sodium, 186, and then potassium, 227. So you can see as you add more energy levels, the radius gets bigger. It's like tree rings, pretty straightforward. So that is one trend we want you to memorize. As you go down the periodic table, the radius increases. But then also need to give us a reason. Okay, here's the one that's a little more challenging and has to do with Coulomb's law, which is my favorite law of all time. So as you go across the periodic table, again, we need to stay in the same energy level. First of all, let's look at the data. As we go across the third level, the radius actually gets smaller as we go across, which seems odd because you're packing more stuff into the atom. The atom actually has more mass because there's more protons and more neutrons. However, you need to remember the structure of the atom. The atomic number 18, that means there's more protons. So more protons means that there's a stronger pull, or nuclear effective pull. You can just say pull, or stronger attraction would even be a better word. There's a stronger attraction for the electrons. And remember, all those electrons are in the same energy level, so they're about the same distance, but the more protons you have pulling on the electrons, the more it can pull them in, which is why the radius gets smaller. So as you go across the periodic table, the radius is going to decrease because you have the same number of energy levels, but there are more protons, they have a more effective pull, they can pull the electrons in more. There you go, that's it.